Alright, here's our next concept, LeChatelier's principle. It's how we can regain equilibrium when we're doing different things. So, LeChatelier's principle, if something is changed in a system at equilibrium, the system will respond to relieve the stress. There are three different kinds of stress that can be applied. The first stress is going to be concentration. If you add reactants or increase their concentration, the forward reaction will speed up, so more product will form. Equilibrium will shift to the right, and then the reactants will move to the products. If we look up here, by doing this, it is as if we're increasing the amount of H2O we have. If we're going to have more than 4, therefore we're going to have more than 4 here and more than 2 here. It's as if the equilibrium is increasing. So if we add more, we have to add more here as well so they can stay at equilibrium. Same can be true. So again, changing concentration. If you add products, if we add product or increase the concentration of the product, the reverse reaction will speed up. So more reactants are going to form. Equilibrium will shift to the left, and the reactants and the products will shift to the reactants. That's as if we're adding more hydrogen and oxygen up here. Therefore, then we'll make more water as well at equilibrium position. If you remove the products or decrease the concentration, the forward reaction will speed up. More products will form and it will shift to the right, and the reactants will move to the products. That's as if we remove some of the hydrogens and some of the oxygens disappear. If those disappear, then we will make more of them until we're at an equilibrium position. So more like this. And then we'll balance out to probably get the, just balance out a little bit more. The next one is if we remove reactants or decrease the concentration of the reactants. The reverse reaction will speed up. More reactants will form and equilibrium will shift to the left. So our reaction arrow goes pointing toward the reactants. We can use this to control how much yield you get from a chemical reaction. Our second type of stress is temperature. Reactants can either require energy or release heat. These are endothermic or exothermic reactions. An endothermic reaction speeds up at higher temperatures because it wants to take heat in. So it's taking heat in, it will create the fast reaction at higher temperatures. Exothermic reactions want to expel heat, so if it's already hot around it, it will move slower. But if we lower that temperature, it will speed up. All reversible reactions will be exothermic one way and endothermic another way. As you raise the temperature of the reaction, the process will go in the endothermic direction. As you lower the temperature of the reaction, the process proceeds to the exothermic direction. So higher temperature, endo, lower temperature, exo. The third type of stress is pressure. If you increase the pressure, the product will shift to the least amount of gases. So if we look here, we have our high pressure. Here we have 2 gases. Well, if we count the number of moles, we have 2 and 1, which gives us 3 moles here and only 2 moles here. So therefore, we're going to shift to the right because there's only 2 moles of gases here. At low pressure, the opposite therefore is true. So if we're starting with 2 moles of gases here and 3 here, at low pressure we'll shift to the left and not to the right. And that is the end of LeChatelier's principles.